Hi everybody, today we are going through Numpy, which is a library in Python. And this library enables us to work with arrays, which are just data structures, which are, well, they store data in rows and columns, okay? So if this data structure, this array, contains only one row or one column, then it's called a vector. And if this array contains data stored in several columns and several rows, then it's called a matrix. And if you have a hard time just visualizing this array, think of Excel. Probably you already have some experience using Excel. And if you plot your data in a column like this, well, then it's a vector. If you plot your data in several columns like this and several rows, then it's a matrix. But anyway, in Python, we call these arrays. And if you want to import the Numpy library, you can import it as np, because then you just write np dot and the function name to access the function stored in the Numpy library. And we're going through two ways to create arrays. One is by using a standard data structure. This can be the zero matrix, which is a matrix like this, or a zero vector like this, consisting only of the integer 0. It's often used to just make space to store other stuff or other numbers. And you have a matrix of ones, then every single entry is equal to 1, or the identity matrix, where the diagonal is 1 and everything else is 0. So if we just type, or if we import the Numpy library, and we want to make a 0 vector, then we have zeros here. Well, actually, we do not need this. We can do that. And here we have told Numpy zeros function that we want a vector of zeros, and we want 4 zeros. And we print the 0 vector, and we see that this is an array data type, and it consists of, or it contains only 4 zeros. But if we want to have a matrix, we have to supply this tuple or this tuple, and by supplying the rows and the columns. So we put this in the 0 mat variable, or 0 matrix variable, and we have here 3 rows and 4 columns, each containing zeros. And I told you that we can have a matrix of ones, and we can easily make that with the ones function. Okay, so, and we can also use the np.identity function to specifically give you the identity matrix with ones on the diagonal. And the identity matrix, it does not take two arguments, because it's always symmetrical, and which means that it has an equal number of columns as it has rows. So it's a square matrix. That was what I was supposed to say. However, more often we are using some previously generated data or stored data to put into our vector or our matrix. And to transform our data into an array, we use the array function. So if we have two lists here, two defined lists, we would like to create a one-dimensional array, which is a vector because it only has one row or one column. Then we can use the np.array function and we supply the list of numbers. We put this into the vec variable and we want to see the type of the vec variable, and it's a Numpy array. And we can plot the vector, and it's an array with 1, 2, 3, 4, and 5 as the entries, because we defined our entries here and passed this into our array vector variable. And we can also find the length and shape of this array variable, and we can use that by supplying the length, which is the number of rows, even though this is printed as a column vector with only one row. By default, the vectors are defined as row vectors. So it has many rows and only one column. And here we see that it has 5 rows. So rows are going down, columns are going across. And the vector dot shape method can give us the shape of our array. So this has 5 rows and 1 column here. Just be careful, because this shape method, it does not take parentheses, because if you have the parentheses, then you get an error. So then we get the tuple, which contains the dimensions of the array. And you can create a two-dimensional array, which is by definition a matrix. So then we can supply 2 lists, which are 2 columns in this array. We put this in the mat variable, and the type of the mat variable is still a Numpy array. And if we plot the matrix, then we see that we have these 2 rows, but we print the number of rows. So then we have 2 rows and we should have 5 columns. And when you define a matrix, you always define the rows first here, and then the columns last. And we have worked with lists, and you can slice arrays just as you slice lists. Because here you see that we have one like list here and one list here, which are defining the inner structure of this array. So for example, if we would like everything in the outer array, space 1 or index 1, we get this lower row. But if we would like to have one element from this lower row, we would have to specify the row here and the column index here. So the row index 1, this is index 0, this is index 1, and column index 0 would be column index 0 here, which is the first column. So we can see here that we have accessed the number 6, which is the first entry on the second column. And the benefit of this Numpy array structure is that matrix algebra works a lot smoother than if we had used lists, for example. So for example, we have two 2x2 matrices here, and 2x2 means 2 rows and 2 columns. And then we just matrix multiply these together with the dot function, which gives us 8, 5, 20, and 13. And the reason why you got 8 is that you had the first row in the first matrix times the first column in the second matrix. So it's 1 times 4 plus 2 times 2. So 4 plus 4 equals 8. And this 5 comes about from multiplying the first row here with the second column in the second array. So it's 1 times 3 plus 2 times 1, which is 5. But you will not find matrix multiplication on your exam in this class. So we are going to use Numpy because of fast element-wise array functions. So for example, here we have two lists. List 1 is 1, 2, 3, 4, 5, and list 2 is 5, 4, 3, 2, 1. And then we would like to multiply these entries together to create a third list. So if we try this, then it's not possible. We get an error. But if we want to multiply this list with this list element-wise, then we can perform this with a for loop. So here we have the third list, the list prod, which is an empty list. And for item 1 and item 2 in with a zip function, we take 1 by 1 of the elements from the list 1 and list 2. Put them into item 1 and item 2 and multiply them together. And then we get the product, and we append this product to list prod, which is the empty list. So the products of the elements in list 1 and list 2 will be put into our list. And then we want to we want to see what is in our list. And it's 5, 8, 9, 8, and 5, because 5 and 1 is 5 times 1 is 5, 4 times 2 is 8, 3 by 3 is 9, 2 by 4 is 8, and 1 by 5 is 5. But it's easier to do this with arrays, because arrays, they come with, or Numpy arrays come with a lot of useful methods. So for example, here we define our list of numbers as an array, a Numpy array, and we store this in array 1. And we do likewise with the second list. We put that as an array and store that as an array to a variable. And now we can just use the Numpy's multiply function, and we multiply array 1 and array 2, and the result is 5, 8, 9, 8, and 5. And you can play around with the add function, the subtract function, the exponential function, maximum, greater, equal, and so on. For example, we would like to find what is, or which elements are greater than or equal to a second array. So in this case, is 1 greater than or equal to 5? No, that's false. Is 2 greater than or equal to 4? No, that's false, and so on. But these 3 elements of the first array compared to the second array, they are element-wise larger or equal. One benefit of the Numpy library is that we can quite quickly create sequence of values. And these sequences can be used to either make a grid to plot something, or make a grid to find maybe by brute force or numerical methods the maximum or minimum of a function. And we have several functions to do this, but we can use the arrange function to make a range of integers, for example. So here we would like to have 10 integers, and by default the method starts at 0 and ends at 9, because it does not take the last element of this what is called? It's called a parameter. So, but the range function, which is in base Python, it does not give you a range of, or a list, or an array of integers. The range function throws 1 by 1 number, just counting upwards to, but not including the parameter here, or the argument 10. So the range function itself is really just a counting function. So if you want the to make an array with integers, then you have to put this range function in a for loop, which takes time. So for loops, they are not fast. So these built-in Numpy functions, they are incredibly fast because they are often optimized using either vectorization, or they are optimized using code in, for example, C. So we can use the arrange function to start not at 0, but at a different number. And if we type np.arrange 10, 20, we start at 10, but we go up to, but not including, 20. We can also have a different step value, because here we are stepping through one by one. We are increasing by one. We can add a step value. We're counting from 10 to 100, and we are stepping 10 each time. So here we go 10, 20, 30, and so on, up to but not including the last argument here. So here we can print all these numbers, because this can be used as an input in a for loop, if you so wish. Maybe you want to go through each and every element in this vector and possibly check the value, and based on the value and the check, you can change the value, for example. We also have a function called Linspace, and it too does create a sequence of numbers, but it does not take a step value. It just takes a start and stop value and the number of items it should return. So here we have a start and a stop number, which is 10 and 100, and this the number of elements should be 10. So here you can see that we are counting from and including 10 to and including 100. And this makes the Linspace excellent for plotting, for example. And you can increase the number of elements in the sequence. For example, here we changed it to 20, and then we have 10, 14.3, 14.7, and so on. And here you have 20 numbers, from and including 10 to and including 100. Another useful function is the repeat function. And this repeat function repeats each element in a sequence a given number of times. So in this case, we have the sequence 1, 2, 3, and we would like to repeat this sequence, or the elements in the sequence, 10 times. So then we use the repeat function from the Numpy library, and we run this. We get 10 ones, we get 10 twos, and we get 10 threes. And we can also pass in an array. Here we passed in a list, we pass in an array, and we would like to repeat each element 10 times. And this repeat function can also repeat just one element a number of times. But if you would like to stack these on top of each other, kind of, then you can repeat 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on 10 times with the tile function. So here you have 1, 2, 3, 1, 2, 3, and so on. And this tile function also takes a list of numbers or a Numpy array. Numpy also has several functions to create random draws. And why would you create random draws? Well, in finance and economics, as you are studying, then often you would perform simulations. For example, in finance, you would simulate stock prices, for example. And then you would draw random numbers from a distribution, sometimes as simple as the normal distribution, and add that to the stock returns, for example. So here we have, for example, the shuffle method, and the shuffle method shuffles a sequence of values. So for example, my list is defined as this list of numbers, but you can also pass in a Numpy array sequence of numbers. And this the sequence is 1, 2, 3, 4, 5, 6, 7. And if we call the shuffle method and we pass in my list, this is the list of numbers, and this shuffle method is in the random subcategory of Numpy. So think of this as just a subfolder, okay? So in the Numpy library, we look for the random subfolder, and in this we get the shuffle method. We pass in my list, and my list should be shuffled. So just by passing in my list actually gets shuffled. You do not have to write my list equals, but this is enough. So here the numbers are shuffled, and if we run this again, it will probably, or most probably, yield a different result. So we also have the choice method, and it returns a random number from a sequence. And for example, if we look in Numpy library, in the random subfolder, we find the choice method or function, and we pass in my list. And my list is 6, 1, 4, 5, 3, 7, 2, and choice actually takes one number from this sequence. So here we drew 3. But we can choose several numbers, or we can draw several numbers from this list. So for example, we just redefine our list here. So we have this fresh in mind. And for example, we would like to have 2 numbers from this list. And this is with replacement, which means that you can choose the same number multiple times. So for example, if we choose two numbers from my list with the choice method, we get an array of numbers. In this case, a vector of two numbers, 3 and 7. If we run this again, we have 3 and 1 as the result of our choice variable. We can also draw several numbers, for example 4 numbers, which increases our chances of picking the same number several times. So in this case, we chose 1, 5, 6, and then 1 again. And the rand function, it returns a random decimal number from the uniform distribution between 0 and 1. So here we can use the random function, and we tell it to draw two instances here, and these instances, they are stored in an array. So here you can choose as many random numbers as you would like, but these will be random numbers between 0 and 1. We also have the rand integer function, or randint function, which draws an integer number, because these are decimal numbers, and the randint function draws a one integer number from a certain range. In this case, the range goes from 1 to 100, but not including 100, and we would like to have 3 draws. So if we run this, we get an array as the output, and this is a one-dimensional array, which is a column vector. So we can set the seed method, or use the seed method to make our results replicable, okay? Which means that someone else can set the same starting point for our random number generator, or pseudo random number generator, and they would get the same output as we do. So in this case, we have set the seed to a number. So you just specify a number, in this case 1, 2, 3, 4, and then we are drawing 100 random integers. So, or not 100 random integers, one integer between 0 and 100, but not including 100. And every time we run this, we get 47, because we have this seed set here. But if we do not set the seed, then we would get a different number each time we run this random number generator, I mean. So to make your code replicable, then you have to set the seed.